Hello my viewers, welcome once again to my channel Israeli Math Concept. In this tutorial, I'm going to solve this given quadratic equation using completing the square method. Do well to follow me on Facebook and also to subscribe to my YouTube channel so that whenever I drop a new mathematics content, you will be notified. Remember, this equation can only be proven to be a quadratic equation when we open up the bracket and then discover that the highest degree of the unknown variable x is 2. So the first thing we're going to do in this given equation is to open up the bracket, after which we check whether it's a quadratic equation. And we can only affirm to that when the highest degree of the unknown variable is 2. After which we solve the resulting quadratic equation using completing the square method. Alright, let's begin with the solution with this given equation. The question says x minus 2 in brackets x minus 3 is equal to 12. Let's first of all open up the bracket. And to open up the bracket is very simple. Let's take x and multiply the other values in this given bracket. So we have x in bracket x minus 3. Then let's also take negative 2. Then multiplying the same bracket here, which is x minus 3. And that is equal to 12. Now let's open up the bracket. X multiplying x is x squared. Then minus x multiplying negative 3 is still 3x. Then negative 2 multiplied by x is negative 2x. Then minus multiplying minus is plus. Then 2 multiplied 3 is 6. And that is equal to 12. Then let's collect the like terms. Then we have x squared. Negative 3x, negative 2x is going to give us negative 5x. Then plus 6 is equal to 12. But we can still collect like terms in respect to 6 and 12, such that we have that x squared minus 5x plus 6, 12 coming to the left hand side of this given equation, we're going to have negative 12, and that is equal to 0. Because taking 12 to this other side of the equation, there is nothing remaining on the right hand side again, hence we call it 0. Then we have that x squared minus 5x, then positive 6 minus 12 is going to give us negative 6, and that is equal to 0. Therefore, this given equation is a quadratic equation. Why? Because the highest degree of the unknown variable x here is 2. Hence, we solve this given quadratic equation using completing the square method. Let's begin with the solution. How do we solve this given quadratic equation using completing the square method? That is very simple. The first thing we discover here is that the coefficient of x raised to the power of 2 is 1. Hence, we proceed with the solution by saying x squared minus 5x is equal to, we want to take this negative 6 to the right hand side of the equation to change to positive 6. Then I want to find the half of the coefficient of x, and of course the coefficient of x is negative 5. So half of negative 5 is going to give us negative 5 all over 2. Then I want to square the negative 5 all over 2, such that I have negative 5 over 2 all squared. And when I square it out, I'm going to have 25 all over 4. Very simple. Negative 5 multiplied by negative 5 will give us 25. And 2 multiplied by 2 is going to give us 4. Hence, I want to add this value to both sides of this given equation, such that I have x squared, then I will add negative 5 over 2 all squared, and that is equal to 6. Then I still add the same negative 5 over 2 all squared. But because I know that if I square this out, I'm going to get this. So I want to put 25 over 4 here. So I have 25 all over 4. Remember, obviously, the reason why I didn't use negative 5x again is because negative 5x was what that gave rise to this negative 5 over 2 squared. In fact, this is the offspring of this grandpapa. You understand that? Alright, and that is equal to the same thing I added to this side of the equation, I will also add to the other side. And then I have 25 all over 4 at this other side. Then secondly, the reason why I put negative 5 over 2 all squared, but I didn't put it exactly here, is because I observed obviously that there is square on this x. So I want a situation whereby I will have another entity that also contains square, such that I can combine their squares together. Then I have x, then minus 5 over 2, minus 5 over 2. Then I now put their squares together, and that is equal to, I have 6 plus 25 over 4. 6 plus 25 all over 4. Remember, let me repeat again, that the reason for adding negative 5 over 2 all square is because I observed obviously that x here contains squares. So I look for a means whereby I can put the squares together such that I have this, and that is equal to 6 plus 25 all over 4. Then I can now say that this is x minus 5 over 2 all squared, and that is equal to the LCM of the denominator here, which is 4, is still 4. Then remember, 6 is the same thing as saying 6 over 1, such that 1 divided 4 is still 4, and 4 multiplied by 6 will give us 24. Then plus 4 divided 4 is going to give us 1, and 1 multiplied 25, we then have 25, such that we have x minus 5 over 2 all squared is equal to, remember, 24 plus 25 is going to give us 49 all over 4. Then when we take the square root of both sides of the equation, we then have square root of x minus 5 all over 2 all squared is equal to plus or minus square root of 49 all over 4. Little wonder, why do we use plus or minus at the right hand side of the equation? The reason is because whenever you are solving a given quadratic equation, you should have up to 2 roots. And remember that the roots of a quadratic equation are the answers you get after solving your quadratic equation. Hence, that's why we add plus or minus, because the plus or minus indicates the 2 roots of the given equation, such that the square will cancel out the square root mathematically. Then we are left with x minus 5 over 2, and that is equal to plus or minus. Remember, square root of 49 is 7 all over square root of 4 is 2. Then we have x. Taking negative 5 over 2 to the right hand side of the equation, it will now change to positive 5 over 2, then plus or minus 7 all over 2. Then we now have x is equal to, LCM of 2 and 2, of course, is still 2. That is the LCM of the denominators, which are 2, is still 2. Such that 2 divided 2 is going to give us 1, and 1 multiplied by 5 is 5. Then plus or minus 2 divided 2 is going to give us the same 1, and 1 multiplied by 7 is still 7. Then I have that x is equal to, taking for positive first, we have 5 plus 7 all over 2, or x is equal to, taking for the negative also, we then have 5 minus 7 all over 2. Then x is equal to 5 plus 7 is going to give us 12 all over 2. Or our x is equal to 5 minus 7 is going to give us negative 2 all over 2. Such that coming here, our x is now equal to 12 divided by 2, we have 6. And also coming here, our x is equal to negative 2 divided by 2, will give us negative 1. Hence, the roots of the equations are x equal to 6 or x is equal to negative 1. These are the roots of the given equation. Thank you for viewing. Thank you for watching. Remember to subscribe to my YouTube channel, Israeli Maths Concept, and also to follow me on Facebook so that whenever I upload a new mathematics content, you will be notified. Thank you. Remember to share this video. Goodbye.